Welcome everyone to today's Explainer. This is the kind of topic that starts with a super simple question, but honestly, it ends up completely rearranging how you view literally every single moment of your life. We are diving into the ultimate cosmic mystery. Why does time only flow forward? And I promise you an absolutely incredible journey today. We're going to start with something as totally mundane as breaking eggs on your kitchen counter, and we'll take it all the way to some mind-blowing 2026 breakthroughs in quantum manipulation. Let's get into it. Okay, let's dive into this. There's this incredibly strange contradiction sitting quietly right at the heart of physics. If you look at the fundamental laws, I'm talking Newton's laws of motion, Einstein's relativity, quantum mechanics, they literally do not care which way time flows. Seriously, microscopic particles run perfectly forward or backward in all those mathematical models. But then, just look at our everyday reality. You have never, not once in your life, seen a shattered teacup spontaneously leap off the floor and put itself back together perfectly on the table, right? This massive gap between what the fundamental laws permit and our strictly one-way asymmetric reality, it is hands down one of the greatest paradoxes in all of science.
To uncover the truth behind this, here's our roadmap for the Explainer today. We'll hit exactly 6 main stops. First, the Great Time Paradox. Second, entropy and the second law. Third, 6 different arrows of time. Fourth, the past hypothesis mystery. Fifth, Boltzmann brains and quantum twists. And finally, number 6, life in a chaotic universe. So we're not just doing physics today, we're literally uncovering the reasons for your own existence.
Starting off with part 1, the Great Time Paradox. Why time only flows one way in a symmetric universe? So, back in 1927, the British astrophysicist Arthur Eddington coined this deeply poetic phrase for our contradiction. He called it the arrow of time. But to really grasp this arrow, we first have to understand the fundamental rules of the universe that it supposedly defies. And that brings us to time reversal symmetry. Imagine you're watching a movie of 2 billiard balls colliding and bouncing apart. If you played that exact movie in reverse, the physics would look completely identical. It would still be entirely correct. Because at the smallest scales governing those individual particles, time has absolutely zero preferred direction. The laws of nature are just totally agnostic to past or future.
Which naturally leads us to part 2, entropy and the second law, or the statistics of shattered teacups and shuffled cards.
So, if the fundamental laws aren't giving time a direction, what on earth is? Well, to solve our shattered teacup paradox, we have to look back at the work of Austrian physicist Ludwig Boltzmann in the 1800s. He completely reframed this whole mystery around statistics, probability, and just basic counting. He gave us the modern concept of entropy. Now, people often just call it disorder, but fundamentally, it's really a statistical count. Picture a pristine, fresh out-of-the-box deck of playing cards, perfectly arranged by suit and number. There is exactly one precise microscopic arrangement for that specific, perfectly ordered state. But what happens the second you shuffle it?
Now, what's really interesting here is this absurdly massive number, 8 followed by 67 zeros. That is roughly the number of possible ways a 52-card deck can be arranged when you shuffle it. And remember, only one of those ways is your perfectly sorted deck. Every single other arrangement is a high-entropy, disordered jumble. So chaos isn't some mysterious active force out to get us. It's simply that chaos has astronomically more ways of happening than order does.
And this statistical reality is the absolute bedrock of the second law of thermodynamics. It dictates that the total entropy of an isolated system can never decrease over time. Think about a hot cup of coffee sitting in a cool room. The heat naturally flows out and cools the coffee, purely because of probability, leaving you, unfortunately, with a disappointing lukewarm beverage. There are just vastly more ways for that heat energy to spread randomly through trillions of room molecules than to magically stay trapped in your cup. It's a completely irreversible, one-way street. Moving on to part 3, 6 different arrows of time. Let's track the suspects across the cosmos.
Now, here's something that genuinely surprises a lot of people. There isn't just one single arrow of time. Physicists have actually found multiple, distinct phenomena out there that all mysteriously point in the exact same temporal direction. Just quickly running through the suspects, we have the thermodynamic arrow, which is entropy increasing, the cosmological arrow, which is our universe constantly expanding, the radiative arrow, meaning ripples in a pond only expand outward, they never magically converge back to the center. There's the quantum arrow, where measurements collapse states irreversibly, and crucially, there's the psychological arrow, the very fact that you remember yesterday, but not tomorrow.
Thanks to something called Landauer's principle, we actually know the psychological arrow is directly tied to the thermodynamic one, because physically recording or erasing a memory mathematically requires increasing entropy.
But there's a really fascinating exception here, the weak force. When physicists were studying these subatomic particles called neutral cons, they found what's known as CP violation. Basically, it means there is exactly one known fundamental physical law with a tiny built-in time asymmetry. No way, right? It proves perfect time symmetry actually isn't an absolute rule of nature. But, and it's a big but, this anomaly is way too minuscule to explain our everyday reality. We still have to look somewhere else for the true origin of our everyday arrow of time.
Which brings us to part 4, the past hypothesis mystery, tracing cosmic order all the way back to the Big Bang.
So, the crucial point is this. If entropy is always increasing, and we run the cosmic clock backward, the universe must have had lower entropy yesterday, even lower last year, zooming all the way back to an incredibly, mind-bogglingly low entropy state right at the Big Bang. But just how low? Well, physicist Roger Penrose ran the numbers on the unlikeliness of our early universe's specific starting conditions, and he arrived at this absolutely staggering figure, 1 in 10 to the power of 10 to the power of 123. It's a number so outrageously huge, it literally makes the total count of atoms in the entire universe look like a joke. Why was it so low? Because in a universe dominated by gravity, a smooth, evenly distributed soup of matter, which is exactly what the early universe was, is actually a state of phenomenally low gravitational entropy. Clumped matter, like black holes and galaxies, that's high entropy. Why our universe started in this mathematically absurd, perfectly smooth state is still one of the deepest mysteries in all of cosmology.
Let's jump into part 5, Boltzmann brains and quantum twists, disturbing philosophical monsters and some wild 2026 breakthroughs.
All right, we're gonna pivot from that vast cosmic scale to something deeply, deeply unsettling. It's a philosophical monster born purely from the statistical nature of the second law. I want you to seriously think about this for a second. If the universe lasts for an infinite amount of time in a chaotic high-entropy state, eventually, just purely by random chance, particles will jostle together to form ordered structures. Statistically speaking, it is infinitely more likely for particles to randomly form a single, isolated, fully conscious brain, a Boltzmann brain, floating in the void for 1 second with completely false memories of an entire life, than it is to form our massive, beautifully ordered universe. So, how do you know right now in this exact moment that you aren't just a Boltzmann brain? Yeah, sorry to induce a sudden existential crisis there. But hey, thankfully, theoretical physics is on the case. In December 2025, researchers Wilpert, Ravelli, and Scharnhorst at the Santa Fe Institute published a paper completely exposing that this entire disturbing debate actually relies on circular reasoning. They proved that depending on whether you mathematically anchor your analysis at the Big Bang, or if you anchor it in the present moment, you get completely different answers about the reliability of memory and time. Now, they didn't totally kill off the Boltzmann brain, but they brilliantly exposed the hidden logical assumptions in our physics that allowed that monster to exist in the first place.
Let's move along and see how this builds into an astonishing late-stage twist. For the longest time, the quantum measurement arrow, the fact that observing a quantum state collapses it irreversibly, was seen as completely fixed, done deal. But in early 2025, theorists at the University of Surrey proposed that the math might actually allow for perfect time reversal in open systems. Fast forward to February 2026, and researchers collaborating with Los Alamos published a genuinely groundbreaking paper in Physical Review X, taking this straight from theory into physical reality.
And here is exactly how they did it, totally demystified. Step 1, they built a control Hamiltonian. Basically, it's a mathematical way to carefully apply pulses that emulate the effect of a measurement without fully disturbing the system. Step 2, they monitored this quantum system with continuous, super precise real-time feedback. And step 3, by actively canceling out or overcompensating for the disturbance, they were able to stretch, blur, or rigorously statistically invert the quantum arrow of time. Now, just to be super clear, this is not some sci-fi time machine for humans. You're not going back to visit the dinosaurs. But they definitively prove that at the quantum level, the arrow of time is highly malleable. It can actually be mathematically reversed through precise engineering.
So why does bending the quantum arrow of time even matter? Because it has massive real-world impact for all of us. This new framework allowed researchers to design actual measurement engines that harvest usable energy purely from the act of observing a system. It's basically a real-life Maxwell's demon. It also paves the way for vastly improved quantum state preparation and error correction, which directly upgrades the exact superconducting qubits we use in today's most advanced quantum computers. We are literally manipulating time zero to power the technology of tomorrow. How cool is that?
Finally, we reach our last stop, Part 6, Life in a Chaotic Universe. Temporary islands of order in a sea of decay. So, if everything is fundamentally drifting toward decay and high entropy, how do you, a highly complex, beautifully ordered biological being, exist at all? Well, the answer lies in systems. And this brilliantly illustrates our point. The second law of thermodynamics only applies strictly to isolated systems, like the universe as a whole. But you, as a living organism, you are an open system. Every single time you eat a meal or breathe in oxygen, you are maintaining your own miraculous internal order, specifically by dumping waste heat and chaos outward. You act as this temporary island of order, actively resisting the universe's decay. But you can only do it by paying the tax of increasing the overall grand entropy of the cosmos around you.
Which brings us right back to your mind. Your reliable memory formation is thermodynamically bound to that exact same entropy increase. Your personal timeline, your very subjective experience of remembering a fixed yesterday while stepping into an unknown tomorrow, it isn't just some neat trick of the brain or an illusion. It is intimately, physically bound to the exact same thermodynamic laws that melt ice cubes and expand the cosmos.
We've really traversed it all today, from shattered teacups to the Big Bang's impossibly low entropy, from the dreaded Boltzmann brains to the incredible reality of quantum time manipulation in 2026. Ultimately, every single time you form a new memory or watch a glass shatter and not reassemble, you are directly witnessing the ongoing shockwave of a 13.8 billion-year-old cosmic event. Our universe started in a state of impossible perfection, and we're just here, simply riding the beautiful, chaotic wave of its unspooling. Will we ever definitively uncover why it started that way? Well, that is the ultimate question waiting for the next generation of physics. Thank you so much for joining this explainer. I'll catch you in the next one.